I'm Dave Mackenzie, the Principal of Creative Technology and Visualization at Oricon, and I'm here with Mike, my real-time technical lead. So we look after sort of R&D, experimentation, and visualizing all kind of our large-scale projects. Most of the projects we work on are massive infrastructure, roads, airports, stuff like that, which Mike will run us through today. The engineering game, that's Mike's title. I'm not taking credit for that. But yeah, we're solely in the AEC space, so we're a large engineering advisory firm. Whoops. And Mike, do you want to?
Thanks very much, Dave. All right, so as you can see, we're a large global multidisciplinary engineering consultancy. We've got 7,000 staff in 80 offices. We've been offering visualization as a service for 15 years now. Obviously, it's not a large part of our core business, but it is something that we have been doing for quite a while. And we're on a pretty exciting journey down this real-time space. So we first looked at real-time going back more than 10 years ago. I don't know if anybody remembers back then. There was things like Quest 3D, the kind of node-based real-time engine. RTRE, which was the real-time rendering engine plug-in for 3ds Max. Unity was always Mac only back then, and I remember it was kind of off in the distance and we could never touch it because we were a heavy Windows-based company. I wanted it so bad and I could just never get it. So, as soon as they released it for Windows back in, I think it was the early 3 cycle, we pretty much jumped straight onto it and we delivered our first real-time project using Unity in 2012.
Earlier this year, in about March, we were acquired. Unsigned Studio, formerly Studio Magnified, and we sort of brought into Oricon a team of about 28 people, or 25 I think came with us, and our focus has been kind of high-end pre-rendered visualization for sort of marketing, bids and design development. We also had a little small R&D arm which sort of focused on experimentation and what kind of bleeding edge technology could we bring into the commercial realm, and a lot of that was focused on Unity as well. Like that was kind of our platform for delivering our weird experiments and whatnot. Just some quick stats. Combined with Oricon, our now combined offer, we've serviced over 239 global clients. We've delivered 128 films, which doesn't sound like many when I wrote it, but it's a lot. It's a lot of hard work. We've delivered work in 15 countries. I think this one's really exciting on a project count. 50% of our projects are delivered in Unity at the moment, which we think is good, but not on a revenue basis. There's over 100 Unity-based projects as part of that. We currently got 40 staff around the world. Sort of Melbourne, Sydney and Brisbane is where the core of our team is. We have some in Asia as well, and also a pretty good contingent in South Africa as well. One of the things, this is kind of a goal we have within 2 years to be completely real-time for how we deliver all our work. It's somewhat aspirational, I think. It's underpinned by requiring talent, people, and the technology, but it's what we're shooting for.
All right, so back onto engineering. So engineering is hard. I mean, it's really, really hard. Some of the things that make it hard in today's day and age is the fact that we have huge, complicated projects with multidisciplines, model coordination. We're working with big teams, globally distributed. It's hard to do things like evaluate multiple design options, reducing risk during the design phase, things like being able to interrogate the models for BIM metadata, which is only going to get more important as we move into LOD 500 down the track. Things like multidisciplinary clash detection. How do we connect to asset management databases in real time to pull that information through? How can we do things like analyze sunlight and shadow? How can we actually end user test the design to make sure that it is fit for the purpose for which it was originally designed. And there is a huge external pressure these days to get projects right the first time. We see it a lot in the news. There's massive projects that are going well over budget, and it costs hundreds of $1,000s per day for every day that they're over. So there's a lot of challenges these days. So how do we make it easier, and more specifically, how do we make it easier through the creation of smart visualization tools? So some of the things that we can do is we can help to introduce a single visual language that puts everybody on the same page with the same level of understanding. We can help through rapid project creation, faster design iteration, giving everything that we do a consistent look, feel and toolset functionality. We can enforce minimum standards of visual quality through our visual tools. We can build kind of these bases that let us very quickly expand into all sorts of new tools and technologies. We can do things like build brand and become a key differentiator for your company. And the way that we do all this is through a framework. So the definition of a framework is it's an essential supporting structure of a building, vehicle or object. And in our case, we refer to framework as the thing that we build inside the Unity editor that helps the content creators actually push content out. So it means that, like one of the goals of creating a framework is that you want every real-time visualization that's company branded that goes out the door, you want that to look the same, feel the same, have the same level of functionality and just work the same. So, visualization is evolving. Over time, we're finding that a part of our business, part of our visualization business, is actually starting to move into the development of more engineering type tools. And so SiteLab by Unsigned Studio, that is the name of our framework, and that's our response to that. So now I'm going to give you a demo of SiteLab. So this is a demo of the end user build that we will distribute to a client, and then further on in the talk we're going to actually open up the Unity editor and start to look at those kind of smart editor tools to support this. Alright, so this is what you see when you first open up the project. It's a fully interactive 3D viewport. You can see that it's got a nice kind of uncluttered interface. It's the same unified interface regardless of whether it's a desktop or mobile. Everything just kind of looks fairly modern. I'll run you through all the different features that we've got because it's got a lot of things that are pretty typical to more CAD type viewing, like 3D model viewing software. But one of the things that we really try to focus on is if anyone's used kind of some of those 3D CAD software, they can be quite complicated. So it's very much about simplifying the user interface for people that aren't necessarily used to using that type of software. So just very quickly running through some of the features. Thanks. So we've got the layer system where you can have you toggle objects on and off. We can have unlimited nesting of layers. So in this case, we could turn off the architectural and still reveal all the underlying services and the structural components. Turn everything off. We have multiple camera types. So the default camera is this kind of orbiting camera, and if you've used something like Autodesk InfraWorks, it's kind of behaves similar to the default camera there. But then we can have free-flying cameras that let you kind of zoom around in first person. We can have first-person cameras where you can drop a pin and suddenly that puts you into that spot. I'll just turn these layers back on. And then we can do things like have predetermined animated cameras, and you can see down the bottom of the screen we have the playback controls. We can have multiple animations on this animated camera and it will loop through those, or you can set it to repeat or just end. At any point you can kind of pause it and you've got full control, and then if you hit play again it'll snap you back to that view. Now, one of the cool things about the animated camera is that it's actually a playable director that's driving the animation. So even though for this example it's just a fairly basic camera movement, it can be a full timeline sequence with lots of things happening. So for instance, as the camera moves, we could have the sunset, and as we come along here we could have the kind of the roller door that's as part of the design, that could move up and a truck could come out, and a whole bunch of stuff. We've done some experiments with some pretty complicated timeline sequences, which is pretty great. Now we've got this menu here called the extensions, and that's the logical place where we would put more larger pieces of functionality that you can drop in and out on a per project basis. So not every project needs to have the same extensions, and some projects won't have any extensions. But a couple of examples we've got is, for instance, if I just zoom out a bit, we've got this optioneering extension where you can basically switch between two different options, and you know, here it's the road out the front, but if it's a large infrastructure project, it could be a whole intersection for that. Again, it's for that kind of rapid design optioneering. The optioneering is completely separated from the layer system, so you know, you can turn off that whole system, and the reason I say that is because in an earlier iteration of the framework, we found that people were actually using the layer system as a bit of a kind of a faux optioneering system, so we kind of made that split so that they're two definitely different things. Something else that we have is the model information, and once that is selected, I'm just going to turn off the architectural layer to make it a bit more clear. Once you've got the model information extension loaded, you can hover over objects and you can see that it highlights them, and then if you click on those objects, it reveals all of the BIM metadata associated with those objects. And then we can also do things like isolate and frame just those particular objects as well. And then we have various graphics settings and a debug mode at the bottom, which is quite helpful. Now, you can do things like click on the project name up in the top left. It gives you a bit of information about the company, but then you can also click on the SiteLab logo. It gives you a bit of info about the product itself. And now, moving away from the top menu, we've got this persistent side menu that gives you access to some tools that you probably use on a fairly regular basis. If I turn this back on, maybe I'll change cameras. So, for instance, being able to do that sunlight and shadow analysis, you can basically change the time of day for any day of the year. And it's all physically accurate as well, based on the location that you set up inside the project wizard. You can also specify whether, you know, different weather conditions as well. And this one here just lets you know exactly where it is that you've specified for the project location. We also have a kind of a persistent menu here for measuring, and we plan on expanding our different measurement tools quite significantly. At the moment it's fairly linear type measurement tools, but once you've actually drawn out the measurement, you can kind of go back and move things around and add new points, and I think you can close it off and it will give you an area as well. And we bin that, and then we can do things like take screenshots. If we just bring up the screenshot tool, it's got your nice visual guide, so you can compose a nice photo, choose whether or not you want the UI to be visible or not, and then the resolution multiplier. But then we've also got this markup tool as well, so you go into this mode and then you can start to, you know, draw. We've got painting, erasing, and also recording kind of text as well. And then you can save that as a file on your hard drive. So look, I think that's about it for the visual demo of the SiteLab framework. So I'm going to jump back into the PowerPoint slide.
I think one thing Mike didn't mention is all of that is tablet, desktop, and VR ready. So there's a headset plugged in that's firing straight away.
You're absolutely right. And that was on my list to mention because it's pretty cool. We're pretty proud of it. So yeah, if you've got a VR headset plugged in, it automatically detects that and it registers it as a new camera, which from the cameras drop down, you just drop your pin in the world and it puts you in there in VR. And all the functionality that we've got also works in full VR as well. Thanks, Dave. All right, so, you know, that's what it looks like now. Sweet, but like there is, you know, we did not get it right the first time. This is like a 5-year journey for us to get to this point. So I'm going to kind of take you right to the start of that journey just so you can see like kind of where we started from and some of the challenges that we faced and what we did about it. So to start with, we had no framework. And the reason for that is because when we delivered our first project, it was to RMS, the Roads and Maritime Services, so the transport for New South Wales Transport Road Authority. We delivered a project to them first. They really liked it. They said, "This is great. Now I want you to do another project straight away." So we didn't actually ever get time to sit down and go, okay, what do we need to build to support this? We just started going from project to project to project, and we found that we had a bunch of issues. So we had a couple of teams across the business that were delivering these isolated projects. They weren't communicating. You know, every project, actually, we just used a copy of the last project, and then we had to go in and change a whole bunch of stuff. The interface in particular was horrible, and I'll actually show you the horrible interface in a second. where it was all kind of hard coded. So the layers down the side, if the amount of layers changed, you had to go in and change code in like 1,000 different places. It was terrible. It was really, really hard to write any sort of custom functionality. You needed to know quite a bit about Unity to be able to actually navigate through these projects because there was no sort of help that we provided. Bug tracking, non-existent. Inconsistent visual quality because there was a couple of different teams doing this. There's no sort of overarching framework to say, hey, with a built-in post-processing stack, for instance, that says, hey, this is the minimum standard, stick to this. So we're having things that were going out. Some things were looking okay. Some things were looking absolutely terrible. It wasn't a good look for us. This is what the first 3D interactive visualization looked like, as we called it. So you can see that like everything is on the screen at the same time. Nothing is hidden or abstracted away behind menus. So there's a lot of information that hits you. You can see the layers on the side. There was no kind of layer groupings. You have to turn on like these little legends. There's like a help that you can bring up. The time of day was terrible. It was very limited. It only ever like gave you the time for like the first day of the month. So it was not crash hot. This is like the help that you've got to bring up. We do have multiple cameras, but you access them through the keys. So if you forget like what camera you're up to or what you want to go to, you have to bring the on-screen help back up. And you can see there's no kind of on-screen controls to determine those cameras. So once you're actually playing animation, you're just stuck with it. So that's our pretty terrible example. I've put this screenshot up because I want to show you an example of the code. What I was saying before about
classic hard code it, Mike.
Oh mate, I'll tell you, like if statements, case switch statements, like all over the place, hundreds of them. It was awesome, and I want to show you. I want to show you this picture just to show you that terrible inspector script in the middle, and just like how unintuitive it is. Like, could you imagine if you were like, you had that in front of you, you'd be like, what the hell do I do now? Okay, so all of that led us to what we called Oricon VisRT. That was our first go at a serious framework. We built VisRT probably about 4 years ago now, and this is an example of what it looks like. So we went from that first one to this. And it's the same project, by the way, so you'll also see the increase in visual fidelity that we managed to squeeze out of it. So straight away you can see like everything's been taken off the screen. It's all accessed through this little menu on the left-hand side. The layers are all grouped together much nicer. Logically, we have radio groups and all of that. Uses the Unity's UI, but we first used Daikon Forge. I don't know if you remember, it got deprecated. It was like a pretty good UI system. So you can see that depending on what camera you've selected, they've got those kind of on-screen controls. So you can see that orthographics got a clipping, and then animated cameras, you've actually got a proper playback control, which was really nice.
I think a lot of what is important to keep in mind, all of this, it's not just in the hands of engineers and Oricon staff. We actually ship this to clients. So a lot of this usability stuff is actually super important because it gets given to an assistant for someone who's got to set this up for a presentation where they're going to sort of review a design, and they start picking through and it all hell breaks loose pretty quickly.
Yeah. And I guess following on from that is that it also needs to scale pretty well because like some engineers have like really old laptops and they still would like to be able to run these models.
Yeah.
All right, so that was VisRT. So the good stuff about VisRT was the framework let us automate the creation of certain UIs. So things like the cameras and the layers and the tools like that you access from the menus, you didn't have to manually create any of them. We had inspector scripts where you basically say, hey, look, these are my layers. Press a button, bam, it just creates all that for you. Saved a lot of time, which means it's super easy to tweak during a project. If the number of layers increases, it's like literally like a 10-second job. It abstracted some parts of Unity away from the user. I guess for us that was a good thing because it meant that we could hire new staff and get them kind of like, well, not necessarily hire new staff, but a lot of like drafters within the business and designers, they expressed an interest in it and they're like, oh, I'd like to have a go at creating my own VisRT project. And it meant that we didn't have to say, oh, okay, we'll go and sit through 2 weeks of Unity training to be able to do that. We kind of managed to simplify that a little bit. We did leverage the asset store. I think there was about 6 assets that we had in VisRT. But probably most importantly is we supported it by other kind of internally developed tools and editor scripts. We had this thing called the Oricon Package Manager, which we built to be able to globally distribute tools. So it sits on an Azure platform. You basically create something, you package it up, you upload it to the Oricon package manager, and then anybody else in the business can pull it down. Unfortunately, based on the keynote this morning, it's now redundant because Unity have just built the Unity package manager that lets us also upload our own stuff. So we'll probably start to phase out the package manager in favour of the built-in solution. And then also we built things like smart streamlined material applications. And I'll show you an example of that. So this is basically opening the APM, the Oricon package manager, and you can see you've got a list of all the packages that are available, and you can update them, and you can click on and get all sorts of information. I swear we built this like years before Unity had their package manager. And in this example, we're going to load the material browser. I've sped up the video because it does take a minute to import all the assets. But basically, it then gives you this really nice kind of interface to be able to select objects. And then once you've got an object selected, on the left-hand side of the material application, it shows you what the different materials are that's on that object. It makes more sense in a minute when I click on the survey, I click on the sales. It then leverages like our substance database and just lets you basically just drag and drop objects across. It's like super helpful if you're dealing with CAD data or like Revit models where like one object might have like 20 different materials on it. It's an absolute nightmare. So kind of the creation of these smart tools to support the framework was probably just as important as the framework itself. Some of the bad stuff about VisRT was that, it was good that it was automated, but it had a pretty rigid set of rules, and as soon as you kind of went outside that, you found that it started to kind of crap the bed pretty significantly. So, things were still very heavily tied together. So the UI was still very much tied to functionality, which was tied to scenes. There was lots of kind of inflexible implementations in our kind of code and our game objects. The game objects themselves had a pretty shadowy relationship. It was quite difficult to understand how the whole framework came together. So if you did need to modify it, you didn't quite know like how one game object did talk to another, which talked to another. It still required a more advanced knowledge of Unity than we prefer. I talked about how we tried to abstract parts of that away. We can only do that to a point, and basically it just wasn't a robust base for extension. Now this is, to give you an example of how we couldn't quite abstract everything away, this is like a screenshot of like various parts of the documentation that I created to roll out to the team. I mean, you can see like in the top left, it's like, oh, okay, so if you need to change the layers, go into the hierarchy and go to VisRT, RT, R2, GUI, main menu. Like it was pretty messy. And so, you still needed to know a little bit about the way that Unity worked to be able to do that. The business did like it, so again, we've had it for about 4 years now. We've delivered about 75 major projects inside VisRT. So, the business liked it and supported it, but we knew that it still wasn't quite where we needed it to be. And that's where the latest framework, SiteLab, comes in, and how we're continuing to try and evolve that. So we had a couple of goals for SiteLab. The most important ones that we wanted to build a robust, flexible and extendable framework that really decouples all of the relationships between game objects and functionality models and UI. We wanted to really let the content creators focus on creation through supporting editor and workflow tools. We wanted to update and streamline the user interface. So again, that's that presentation layer over the top. We wanted to make sure that we could build it for everybody. So it didn't matter if you were on a computer or a tablet or a phone, or if you had a VR headset, it would just work. And then the last goal is that we want to start to use SiteLab to augment our pre-rendered film work. Again, going back to that aspirational goal of everything delivered in Unity within 2 years' time. So some of the more technical parts of SiteLab is that we moved away from a singleton heavy design. We weren't actually using a singleton design pattern. We did have a lot of singletons in there, so we're using a lot more solid principles. We have a pretty big reliance on scriptable objects. A couple of years ago there was a Unite talk, overthrowing the mono behavior tyranny in a glorious scriptable object revolution. If you haven't watched it, it is super, super helpful. It really informed a lot of the design decisions that we made around building SiteLab. Scriptable objects are great because they let you do things like have cross-scene referencing and referencing from inside prefabs, and just helps us to kind of remove those hard links between objects. It was built with the philosophy around multi-scene editing. I say that, but now that the nested prefabs has come out, there's a potential that we might actually migrate away from multi-scene editing into more of a nested prefab approach, because even though multi-scene editing is pretty good, there's still a few drawbacks. One of the biggest ones that I can think of is that you can't have references from another scene inside a timeline that's in one scene. So you couldn't have like moving things from a bunch of different scenes all playing within the one timeline. You know, you can, but you've got to really kind of hack it together. So it might be that nested prefabs is the way to go. We have these integration layers for third-party assets. Because we do use the third-party assets, we kind of hide them away behind this integration layer, so that it doesn't matter if we swap it out with another asset. So the Sky system, for instance, that we use, uses Enviro at the moment, but Enviro is the third solution that we've used. We've also used the one that was called Time of Day, and then Tenkoku Dynamic Sky. So hiding them away behind these generic interfaces mean that we can really easily just pop in new assets, and all the functionality of Sitelab will still work. We use an event-driven architecture for more rapid iteration of functionality, and we abstract a bunch of Unity stuff away, which reduces the training time. So we've almost achieved that goal that we wanted, where somebody doesn't need to necessarily know the guts of Unity to be able to use it. Yes, all right, so now we'll go into the live demo. So we are inside a Sitelab project, so you would use the Oricon package manager to add Sitelab to an empty Unity scene. And then what we do is we can either go up to Sitelab and go project setup, or we can just hit F1 on the keyboard, and we're given this big kind of project setup wizard. And this is kind of, I guess, 75% of what Sitelab is as far as the editor tools go. So we have the first thing that you see is this build configuration. So the idea is that because it's multi-scene and we want to be able to target all platforms, you're going to have different build configs for different target devices. So the desktop version might have one Sky asset, for instance, but then your mobile version might have a completely different one. And this is where you kind of set that up. So you've got a few options. The first one is that you can actually go in and start to edit that config. So you can see what scenes we've created in this. This is the one that I created for today's presentation, that we have environment cameras, and then you can kind of go in and see the scenes that all projects have to have that we abstract away. So the UI and the loading screens. And then what you can do is you actually click this button just here, and it will load that whole scene load all the scenes into your environment. The last button is build, so it's basically a one-click build, and if you click that, it gives it a certain naming convention based on your project details. So you can see that we've now got all our scenes in there, and you can see on the left-hand side our user interface. Very quickly, we'll run through the core systems. So the first one is the project details. So you would put in your project ID, and for an engineering company, that's probably going to be the internal project code of that particular project, what the project's name is, the image that you want to come up on the loading screen. We have the kind of the Oricon lady's face, but you could actually put like a project image if you wanted to. One cool thing is that you don't necessarily have to just pick. You can pick something from the editor like normal, or you could actually click this import and just select an image off your hard drive, and just automatically goes through the process of creating a sprite and giving it the right dimensions. Multiple project revisions with the ability to set the dates. And then what the client list is, and that populates kind of when you click on the project information, it shows the client and the client's logo, and you can have more than one, and you can reorder them, you can change the size, and again you can pick stuff straight off the hard drive. Now I should point out that we use scriptable objects heavily for this, and if we come over to the right hand side and go down to our systems, you can see that we have a bunch of systems that represent. So if I go into the layer setup, for instance, this is where we can set up our parent layers, and then have children, and then have children of children. If we click on the layer scriptable object, the layer system scriptable object, it's pretty much the same thing. So we use Odin Inspector to drive that project setup wizard. Odin is pretty much all through our code. It's absolutely brilliant. One cool thing that you can do is if the client wants a particular color theme, then we've got this theme set up. So if we want the Hot Wheels color theme, for instance, it just changes it dynamically, and we're going to be building that into the runtime as well. I'll just go back to the Sitelab theme. Okay, so the cameras, this is where you can add all your cameras, and then if it's an animated camera, it's when you then drop in your timeline this is like a script that we built on top of a playable object. And again, cameras are super easy. You can reorder the way how they appear. You can select which one is going to be the default camera when you start the project as well. Environment system is where you set up the time of day. And you can set, whether or not it's going to have runtime data, where your project is actually located. One cool thing that I can't show you because I'm not connected to the internet, but if you type in this search bar, it hooks into like a Google search, so you can start typing in, wherever you want to be in the world, and then when you select it, it automatically populates the lat, long, and the UTC for you, and then whether or not you have the weather set up. The extensions is basically, again, so things like that model information, the optioneering tool, it automatically registers it and puts it in there to be able to change the options. So if we, for instance, remove like the model information, so yep, you'll see that it's actually disappeared from the left-hand side on the extensions. And then if we add it back in, then it's appeared again, and we can click in there and actually go in there and adjust all the options related to that extension, and then just a bunch of other stuff. So further down is where we can start to put extra things as we develop them. All right, so that's kind of the workflows inside the editor. So what we want to do now is just take you through kind of two case studies. I think two. How are we going for time? All right, I'll take you through two quick case studies for how we've used our frameworks to clients. So the first one is we're actually going to go back to VisRT. And the reason I want to show you this project is, first of all, because it's a really great example of how we can build this kind of massive tool that bolts onto the side of it. And you still get all the existing functionality that comes with VisRT, but then you get something also completely new. And also, this is pretty much what broke VisRT for us in terms of like hacking together this functionality. This is the project that really highlighted that we just don't have a great base for extension. Now, unfortunately, I can't show you the actual projects. We don't have project permission, so instead what we've got is this kind of generic environment that we created more to demonstrate the functionality of the tool itself rather than the project that it was in. So this is the generic signal sighting tool environment. So the first thing is that you see that it comes up with the ability to either load or create a new configuration file. So if we just create a new one, for argument's sake. And what that configuration file does is it saves the parameters of the signals themselves. So in a large-scale engineering project, like because this is an executable file, there could potentially be a lot of them floating around. You don't want to sort of embed any sort of hard information into those files. So instead we use an external configuration file that can become your single source of truth, and that's what they can put up onto their source control, project-wise, or whatever it is that they happen to use. So what we'll do is we'll jump straight in, go to the signal sighting tool, and you can see this kind of screen comes up on the right hand side where it shows what our config file is that we've got. Then we select a track, and then we select a signal that lies along that track. And there's a bunch of information on the screen, but basically everything that's on the bottom of the screen relates to the train driver. So you can choose like how they sit depending on what the rolling stock is, or you can put in a manual height and offset, where they are along the chainage of the control line, and then we can actually start to drive the train. Then everything on the right-hand side is the particular signal that we're looking at, so we can determine where it sits along the chainage, and that's not just moving it in a straight line. If the chainage had curves, it would kind of follow it around the curves. What the offsets are of all the different elements, so masts, signals. If it's got a theatre indicator, what the actual text is inside the theatre indicator. You can snap to the minimum sighting, so from 220 metres out, the signal needs to be unobstructed for X amount of time, and then minimum sighting, which I think is the 6-second mark, and then from 20 metres out, you basically have to be completely unobstructed. So what we did is we gave this back to the client, so they went in there, adjusted all the parameters of their signals, made sure it all made sense, because there's a bit of an issue on that job. It's an elevated viaduct, and they were worried that when you get to the stations you couldn't see through to the signals, so they got everything the way that they wanted it to. Then they exported that signal data, and it's dead simple. It just like basically saves it out to a spreadsheet, which I'll show you now. And then they wrote macros on the design side of things, so that it would read that spreadsheet in and automatically update their design. So that's kind of how we closed that design feedback loop.
Often this was done in real life by like just train dudes walking down the track and like understanding if they can see it or not. So it's kind of from a risk perspective, it reduced a lot of that. So no need to induct people, no need to get people on site.
All right, so the second case study that we want to talk about is some work we did for Brisbane Airport Corporation. We actually did two projects for them, one inside the international terminal and one on the Sky Bridge at the domestic terminal. They were basically going through a wayfinding exercise where they were redesigning all the signage. So what we did is we built those environments in virtual reality, and we let them experience it and go down. We not only walk through the design, but actually start to make design changes directly inside VR. So I'll quickly show you this. Sorry, it's loud.
There's a great anecdote. The head of airport security was using this in VR and understood how the sightlines were affecting their security profile, and from after the VR session, immediately called the manufacturer, sort of make a change in real time, which was a good use of the technology.
Yeah, and again, because it was built in SiteLab, it basically worked over desktop and VR as well. And this basically just shows the way that we kind of packed up the gear and went down to Brisbane Airport Corporation and set up. You can see the head of Border Force, BAC CEO Julianne Alro, she came and had a go as well. So it was a massive success.
I think we're out of time.